Please state your name and title.
My name is Howari. I am a professor of environmental sciences and the acting dean of natural and health sciences at Zayed University in Abu Dhabi, United Arab Emirates.
Okay. Would you please give a brief about your background and experience?
Well, I can define myself as an environmental scientist, and usually environmental scientists look at the environment from two perspectives. One, they view the environment as a resource, and also we view the environment as a hazard. So basically I study the environment from these two perspectives. I use several tools to study the environmental equality. I use analytical chemical tools, remote sensing tools, management tools, and others. So I'm an environmental scientist.
How can the Gulf avoid the peak salt situation discussed and make it more economically suitable?
Well, we can turn the liability into source of profits if we can actually find a good business case for the liability, whether it's salts, carbon dioxide, or any type of liability. For example, for salts, we can actually purify it. We can make it commercially grade. We can use it in the chemical industries to produce acids like HCl. We can produce commercial grades like the food salts and others. We can also use it to develop a technology that I call it low-tech but high impact, which is the salinity gradient solar pond, which is a technology that uses salts in water ponds to store the energy, and then the engineers designed a process, or actually a technique, so that they can retrieve it and produce electricity that can be applied into many applications such as water desalination. So basically, to answer the question, we need to think how we will turn the liability into a source of profit.
Okay, which brings us to my next question. What out-of-the-box solution do you have for the future and immediate solutions for the present?
Well, innovation. We need to be innovative. We need to think outside of the box. We need to think of applications. We need also to think of the immediate return on the investment, and in the same case, in some cases, in some areas, we need to consider patient and a strategic type of investment. So all of these things actually together, they can lead us to solution. They can lead us to find answers for the most troubling questions that we are facing, especially in the field of water, energy, and food security.
What can science do to make salt water more drinkable, things that are not being implemented right now, and help society at the same time?
Well, desalination is the way to go. There are many techniques, actually. There are a lot of new inventions and innovations that is still in the labs, promising, using new membrane materials, using new materials in general, and also, but the question actually is to be innovative in how to hook up the desalination plants, whether it's a classic, new, or innovative, with renewable sources of energy. So to answer the question is we need to think of the problem in terms of providing renewable and clean sources of energy to produce the desalinated water.
Mm-hmm. Speaking of desalination, how do you think we can make desalination safe for drinking, and not only for human consumption, but also for fish?
Yeah, well, when you talk about fish, pretty much we're talking about the brine that goes, which is the waste of that comes from the desalinated water. Well, for any projects, we have to conduct what we call it environmental impact statements. And this is a statement actually will balance the benefits and the consequences. Now, if the benefits more than the consequences, then we will go ahead and put the project forward. But also we need to think about the management plan, environmental management plan. How to transport the brine, where to dispose it, how to recycle it, and so on and so forth. The last thing that we want to think of is disposing the waste. That's not a good option. We need actually to recycle it. We need to reuse it. We need to find an application for it.
Okay. Are there other techniques that you are looking into, perhaps capturing humidity or finding a way to remove salt from the water to make it drinkable?
This is actually, we have a few students working on irrigation from humidity in the Gulf area. During the summer, the weather is so humid. So basically, what we are thinking is that, of an invention, a technique where we can, pump water into coolers, and also having the areas where we will condense the water, have a material that we call it hydrophilic, a material that love water. So basically, when water cool enough, then when the water vapor cools enough, it start actually condensing. Now, if we have a material that loves water, then it will take more of this condensation, and that will make the process even more efficient. But these are actually, again, students' projects, and we encourage it. It's a promising technology that we need really to pay more attention to it.
Okay. How do you think that the Bahrain Science Collaboration Symposium have helped towards finding solutions in that direction? Have it helped, or have the topic not been discussed enough? And have you figured out better solutions because of the symposium?
Yeah. Well, the symposium, it's an eye-opening on a lot of new fields. There were some good talks that reviewed the problems, the nexus between water, energy, and the environment, and the food as well. And they talked about the 3 E's: energy, economic, and environment, the interlinkage and the complexity. And, the symposium also created an opportunity for scientists, not just from UK and the GCC, but also among the scientists from the GCC, open doors and pathways. And I've heard a lot of people, they started developing and crystallizing ideas for a future collaboration. So in essence, it is a successful conference, a successful symposium, and I think we should see more of this.
Okay. Thank you very much, Professor.
All right. Thank you.